Hi, and welcome to Java Programming 3. This is the first session for the last programming in Java course in UCLA Extension. So, one of the things about myself, I am the CTO and co-founder of a company called Gavalytics. We do artificial intelligence on thousands of public and private records to yield an analysis on the biases of judges. And before that, I was doing computer vision algorithms and virtual augmented reality on a company called Seedling. I was running the engineering team there. We developed several iPhone and Android apps, and before that, I was in the special effects industry in Hollywood working for Sony Pictures, where I spent 8 years doing a little bit of everything, and including working on an Academy Award-winning software called Katana. Okay, so the recommended reading. I don't want to call any of these books required reading. And the main reason for that is because those books are just flat out expensive. They're sometimes not that good, and once you're done with a class, you never really open them again. So if you want to go ahead and get one of the books, feel free. I'm hoping that I do a good job here, that I can actually teach you without having to spend the money on that, and probably buy those books that are a little bit more timeless. I do have a personal philosophy with books. I like buying books that are not about a particular technology, but about the theory, because the technology will change in a year or less, and the book will be irrelevant, but the theory will remain consistent and constant for many years. Some of the same things that I learned about artificial intelligence when I was in college in the early 2000s, it's still valid today. The technology changed dramatically, the frameworks changed, the algorithm implementations might have changed, but the theory remained the same. And I'm hoping that I can teach you some of those things. And because of that, in a Java programming course, I never really thought that anybody joined this class to learn Java per se, to learn the Java language per se. What I see is that most people want to become programmers, but it becomes a chicken and an egg thing where you have, well, I want to be a programmer, but at the same time, I don't know how to program, I don't know how to write code, so I'm going to use a programming course. And the programming courses usually teach you things the way that as if you already knew how to program, and that is not necessarily always the case. So there's this chicken and an egg paradigm that I always try to mitigate a little bit as possible by doing a little bit of an analogy. It's like somebody taking a class they want to learn how to cook, but you are taking a class on how to learn how to cook Mexican food. You won't be able to do a souffle if you have taken a class on Mexican food. You won't be able to do a creme brulee or even pad thai or something by learning Mexican food. So in this case, Java is kind of like learning this to see the kitchen, and I can teach you some of the principles of cooking, of one particular style of cooking, and as you switch programming languages, is like cooking in different kitchens. So the Java Beginner's Guide book, I consider it as a good reference for the actual language, but not for programming. The other two books that I'm requiring is one is Introduction to Algorithms, and that book I like it because it helps you with strategies for solving or creating new algorithms. as well as reviewing some of the popular algorithms and techniques for doing common operations. It also talks about efficiency of algorithms and things like that. So it's a good book. The other one is Design Patterns by the Gang of Four, and that is essentially distilling a bunch of problems that have been solved over and over and over and over again into problems categorized so that you can reuse them again. It's like a cookbook at that point, if we're gonna stick to the kitchen analogy. Okay, so how are we gonna be working? The class, we're gonna be doing a lot of hands-on exercises. I'm gonna be putting assignments for working in teams. We're gonna be doing, as we submit some of the code, we're also gonna be doing code review. At this point, you're in Java 3, you should be able to learn and critique some of the code by your peers. And please, nobody take any comment personally. We're here to learn. And sometimes, getting feedback gets you in the right place. We're gonna be doing a quiz in around class number 6, and then a final project that it takes the majority of the grading. Speaking about grading, we're gonna put class participation, that means the homeworks and assignments, 10%. Those are great exercises for keeping your knife sharp, but in reality, the majority of the scoring comes from the final project and from the final exam. The final project is 60%, the final exam is 30%. Our goals, given that we've already learned some of the keywords, or pretty much every keyword with Java, is to show you some of the cool things that we can do with Java. At this point, it's less about the language. At this point, it's more about what you can do with what's existing out there and how to do it effectively and how to do it in the best way possible. So what we're going to be talking about, design patterns. It's essentially, I'm going to summarize that book in one class. We're going to be talking about test-driven development and test techniques. We're going to be talking about algorithms. We're going to be talking about build tools, and this is really useful for whenever you have big projects that have lots of different dependencies. We're going to be talking about client and server applications, the Spring framework. We're going to be doing microservices with Spring and AWS Lambda, and we're going to be talking very little bit about Android. Those are the things that we're going to be talking during this course. Okay, so now let's recap a few of the things that we've learned throughout Java 1 and Java 2, just to make sure that we're up to speed and we don't have to go back and review any of these concepts. Here we have a table of all the keywords that appear, that exist in Java, or at least a very comprehensive keyword table. What is this? It's just essentially the words that mean something to the language, and therefore we cannot use those as variables. You will see here some words that you already know, like new, for, if, while, return, int, char, double, else, etc. I hope that at this point you know what some of these things mean. Another thing that it's really important to understand is what is a primitive and what are the data types that we can use. Primitive is just a very basic ingredient of data represented in Java. So we have booleans, which represent 0 or 1, byte, which represent binary information, basically any type of information, char, a letter or a character. It could be a number but represented as a letter. It's like in an address, you're not really doing any math for the street number on the address, so it's therefore a character. Double is a very precise number, a floating point number that is quite very precise, a lot more precise than float, which is the next one below, which is using only 4 bits. Floating point and double allows us to represent fractions of numbers. For example, pi, it's at a really long number, but it's just we can actually approximate it better in double than in a float. However, we would get a good amount in float. Int is just an integer number, 1, 2, 3, 4, minus 1, minus 3, minus 4. And the range of integer is that it goes from 2 billion to minus 2 billion to 2 billion. What does that mean? That if we want to represent something that it's more than 2 billion, we will need a larger number, something that has more bits so that we can represent stuff. And if we wanted to do that thing, we would use a long, which goes from minus 9 quintillion to 9 quintillion. If we wanted to save some memory and try to go for something that it's just not going to have that much data, rather than using int and allocating so many bytes, we can use a short, which goes from minus 32,000 to 32,000. The combination of those things, actually, those primitives, we can use them in a combined way as an object and basically generate whatever data structure that we find and we think that it's best. Okay, as far as operators, here's a good reminder of some of the operators and the priority of how things are added. So for example, the highest priority is plus plus. That is an incremental plus 1 or minus minus. Then a multiplication and division, then addition and subtraction, then comparisons of equality, then comparisons of both of them occurring at the same time, or one of the other. That's the next one. One is and, the other one is an or comparison, the logical or operator, and the other one, the lowest one, is the assignment. So for example, the expression down here of 100 plus 2 times 10 divided by 4 equals 105, which if you evaluate this operation given this table, you would see that the first thing that gets applied is that 2 times 10, which is 20, divided by 4 is 5. And then the last thing that gets processed is the sum. So it's 100 plus 5 equals 105. Then on the right hand side, we have the tables that describe some of the operators that we just mentioned. What is a statement and what is a block? A statement is a single line of code, or a single expression, a single representation of the minimal unit for a line of code, or for, it doesn't necessarily is tied to a line of code, because for example here we have statement _1 that is concatenated until it finds a semicolon. Java understands a statement from the end of the previous semicolon or a curly bracket all the way until the end of the semicolon. What is a block of code? Block of code is something that is surrounded by square brackets, curly brackets. A block is something that is surrounded by curly brackets, such as this function. The scope of this function, the scope of all the variables there, work as long as they are in a parent or a child can see the variable. So for example, the block of code that is inside of if true, if we had something that is referencing statement 1 or statement _2, it would be visible because a child scope has visibility to a parent scope. In other words, the innermost scope has visibility to the outermost scope as long as they all live in the same ancestry tree. Okay, so some of the control structures that we have, the most basic ones is an if statement, very basic, a while statement, which essentially loops until that condition is met, for loop, which has in the traditional way an initialization, a condition, and an increment. An initialization is just this for loop has a built-in counter, and the initialization takes care of resetting or setting that counter to a specific value to iterate while that condition is met, and every time that it iterates, perform the increment function. As far as the other iteration, is just more like a shortcut, because the for on the traditional for creates a counter or an index. The other one iterates over the objects in an iterator. So you can just directly extract each one of the elements on a list, rather than going and counting all the elements in a list and then accessing them directly. So personally, I prefer the iterator example, because it's also more efficient in memory management rather than doing the entire for loop in the traditional way. So if we mix primitives between each other and generate some data structures and organize them into collections of primitives, and as well as collections of those collections, we can come up with the abstraction of an object. And an object is the other type of variable that Java allows an object as a variable. It's either primitives or objects. An object has different elements, which, it has a name. It has the members, or the variables that it holds a state for each time that it's either instantiated or is at the class member. And one of the things worth pointing out in Java is that the keywords that Java uses, sometimes it's not like the best keywords or the most descriptive keywords. It's more about like I don't know in some cases why they named it like that. Like, for example, the keyword static, to me, just static without the Java context seems to me more that it would do the work that the keyword final does. But whenever they made the language, they decided for whatever reason that static was a better way of describing it. Another element in Java, in an object in Java, is the constructor. And the constructor is basically the function or functions that you can call in order to get a new version or a new instance of that specific object. If you want to see it this way, it's basically just saying a return type, and it's a nameless function. And if you look at if you compare them against the methods, which right now we're seeing here, the methods have the access type, which is public, private, protected, etc. The return type, boolean, int, static, int. Well, static is just a modifier of the actual method, but in this case we have boolean, int, and int. And if we compare it to the constructor return type is the object type, and then we have the name of the function. The other one in the constructor, we would consider it nameless if we want to see it that way. Just a good way of identifying them or thinking about them in as far as like consistency between methods and objects. So those methods just usually have a name that describes what it's going to do, and also has parameters, like in the case of that int x in argument method, the second in the method in the middle. Okay, so we were talking about static and instance a second ago, and if we reference the static versus instance philosophy, I think a lot of people throughout my teaching of Java 1 and Java 2, I realized that a lot of people had a little bit of a hard time understanding that you could keep a variable at a class level, and that when you modify that variable, it modifies it for every single instance of the objects that live under that class. And it's normal, it's already abstract enough to understand that you have a class and that it's a copy of the object that you're declaring and all that. Um, but this is an example that I use to describe a little bit the static versus instance variable. I like using this one. Since we know that a static member or a static function in either a variable or a function, they live inside of the class, and they for that reason do not need an instance of an object to be executed or called or accessed. And the most important thing is that the value is the same for all instances. So if you change it once, you change it for all of them. The instance variable is just stored in the object, not stored in the class. It needs an instance to actually live, and the value is or can be different in all instances. And a good way of remembering that is everybody has a bank account, I would assume. And the routing number is a shared number for every single bank account. So if you were to change that routing number in once, it would change it in all accounts at once. We can consider something similar to a static instance. But a static, we can consider that similar to a static method. But if we were going to do the same thing for the account number, the balance, or the holder, it would be different for all of them. So if we modify one of those, we only modify that instance, but we're not modifying it across the board. And that would happen with the routing number. Okay, so so now let's move into something a little bit more advanced, like passing by value and passing by reference. Okay, so we've got this drawing thing here. So imagine that in Java or in any programming language, what does it mean that by passing by reference? So imagine that you have your computer's memory that represents a memory, and you have essentially cells that represent the amount of memory that you are going to use in your program. So you can be storing here an int, which is kind of like a known size type, and then you can be storing a boolean and a float and int and whatever, right? So as you are creating new functions or whatever, it's easy enough to just duplicate the value and pass it and make it a copy and just pass it in for the next function so that it could be modified and then processed. What happens when you have an object? When you have an object, and let's just represent it a little bit more like a JavaScript object notation. So you have or JSON format. So you have a string, and then a value, which would, let's say, an int, and then let's put the next one would be another object inside of another object. So we can do like key2 pointing to value, key3 pointing to value, another thing, and then we can have essentially 3, 3 to 1. So essentially we could have like all sorts of complex data structures that have nested variable levels. And for the compiler, this thing, just calculating how much memory it is using, is much more complicated than just grabbing the address where this starts and being the thing that is being passed. So that's being called pass by reference. It's easier for the computer to just tell you, oh, go to look for the parameter in this address and essentially take it from there. It's faster to copy primitives because they're of a known size, and it's faster to copy the address of an object because that's also a known size. The size of an address in memory is the size of 32 bytes, 64 bytes or bits. 32 bits, 64 bits, whatever the memory and word size is in your computer. So makes things a lot faster than having to deep copy the entire set of values inside of your computer and then duplicating it, essentially making the process less memory efficient. So the rule of thumb is whenever you are passing a primitive as an argument in a variable, in a method, you are passing by value, and when you are passing an object, you are passing by reference. So those are two things to keep in mind, because sometimes you might find a bug that you thought you modified an object, or you thought you were actually not modifying a primitive and you were. And well, so those are things are to keep in mind when things are being passed by value and when things are being passed by reference. The other one is receiving variable length arguments. So we have arguments like this boolean that is this is cool string ... x. That means that you are receiving an array called x. And what that means is that you can pass as many arguments as 0, 1, 2, 3, 4, 5, and you don't have to worry about the formatting or how many arguments you're passing, or even if you are passing an array or not. So it just becomes much more natural when you're calling a function just to be passing arguments in a printf style in the case of C or even Python. Okay. Generics. Generics is one of those cool things that, imagine that you wrote this code and you're very proud of how it works, but then the client comes back and they want to modify it so that it works with the current code and with a new data type that you have. So generics allows you to essentially templatize or do a live search and replace in the compiler for data that is generated. So for example, all these t's in the environment are going to be replaced with whatever data type that you declare that this DIY stack element is. So we can use it and restrict it only for a string if we want to at runtime, but also create it for a date, and that will be only limited to that specific object only. Lambda functions. Lambda functions is something that is that was essentially jammed into Java as it became more popular in other languages. It's one of those things that Java is catching up to the innovation of other languages. But basically, it's a function that is not declared as a function because it's theoretically simple enough that you can just write it on the fly without having to worry too much about creating a new function, creating a new object, etc. You just declare a Lambda function, and that gets passed as an argument to some other function. So it's really useful for callbacks or things where you are passing types of executable code into as arguments. So for example, that collections.sort is passing a quick Lambda function as a way to reverse sort the list because it's doing, instead of comparing A to B, it's comparing B to A, and essentially is creating a new function where it's doing a reverse sort of the list, the linked list that we had before. Okay, methods and references. So speaking about passing our functions as arguments to a function, to a method, we can do that by either using the double semicolon as a mechanism of like passing the function. So for example, the constructor is essentially semicolon semicolon new. Same thing for the class or object method. So for example, the same way that we were doing it with a Lambda function, the same example as before of sorting, reverse sorting the array, is now being done by the myCompare function, and we are now passing it as an argument. So whenever that collections.sort is going to sort that list, is going to use the comparator, the comparison method that I am providing in the myCompare function. Okay, so the basic stuff of also one of the big advantages of Java is that it came built in with threading support, and which makes it really easy and really nice to perform tasks at the same time concurrently. So we have as long as an object is implementing a runnable interface, then it can be run as a thread. The other alternative is just for whenever we are already, the easiest way is by inheriting from the thread object, or by implementing the runnable interface. The thread object already has some built-in bells and whistles that otherwise you would have to do it with the runnable interface, but in both cases it's the same. The other one is a slight shortcut to the other.